regression and probability is not something we had a lot of time to do. Usually this would probably be the very last thing we do before the EOC, but I figured let's throw it in there. It's not a very difficult thing. It's one of those where it's just basically purely calculator dependent. So I'm just going to show you how to use the calculator on this. That's all you're going to need it for, and then maybe show you one or two things. But there's not a whole lot of writing that I'm going to do here. It's mostly going to be the calculator. So my example, let me walk you through kind of what I did. So the example says a scientist wants to measure the growth of a small bacteria population. He starts with 100 and counts the number of bacteria each day for a week. His results are shown in the table. So what we're going to do is we're going to go to our calculator, hit the stat button, okay, and then edit, the very first option. This is going to give us the option to edit our list. Now, if you already have information in that list, I believe you can clear it by going up and hitting clear. Does that work? Oh, and hitting enter. Yes, okay. So we'll do that for list 1. We'll hover over that. We'll hit clear, and then we'll hit enter to confirm. So I'll put my x values in list 1 and then my y values in list 2. So in this case, I'll put days in list 1. So day 0, 1, 2, 3, 4, 5, 6, 7. So again, you're just putting the numbers in there and hitting enter. List 2 will be the bacteria. Make sure that these line up properly. So day 0 is 100. Day 2 is, or day 1 was 165. Day 2 is 278, 452, 735, 1199, 1934, and then 3055. It's helpful, by the way, to just double check that you typed everything in correctly. Make sure both columns are the same exact amount of numbers. Because if one number is a little bit off, then the whole thing is going to be a little bit off. So just make sure it's plugged in properly. Once you've checked, and it is, go back to stat again. Everything's going to be located at that stat button. Scroll over to calculate. Now this is where things are a bit up in the air. So we're going to select a regression here. You can see like number 4 says L-I-N-R-E-G. That stands for linear regression, so that's for like a line. Number 5 is quad regression for quadratic regression. And then cubic, then quartic. There's linear regression again. Don't know what the difference is. But we're going to scroll down. Now the thing is, you'll see part A says write exponential function. So we're going to look for exponential regression. Obviously none of those says exponential regression. So number 0, or number 10, or whatever you want to call it. EXP. REG. That's going to stand for exponential regression. That's the one we're going to use. Okay. This just says it's using list 1 and list 2. That's fine. Make sure yours just says that, and then hit calculate. And now it gives us an exponential equation. Now you can see the equation. Let me see if I can use my little writing tool here. You can see the equation is a times b to the x power. So it's a times b to the x power is kind of how we typically write it. It's telling us the a value is 102.37, so this would be 102.37. Round it however the question would ask you to round it. The b value is 1.63, and to the x power. So part A says write an exponential function b of t, so that would just be b of t 102.37, 1.63, and then use t as the exponent instead of x, because it does say b of t, and it says in t days, so using t instead of x. So there's your function. That's part A. And now part B says how many bacteria can the scientists expect to have after 2 weeks. And what we're going to do is just take this function and plug in a number, essentially. So let me write the function down first so that I have it. All right. So we can go back to our y equals. Let me go ahead and get rid of this first. All right, go back to your, not y equals, but just, I guess, quit out of this. All right, and use that function that we just got. So 102.37 and then 1.63. And now, so that's 2 weeks, right? We're not going to plug in 2, though. That's the things most people do. We're going to plug in 14 because notice our x values are in days. So we need 2 weeks in days, and 14 days is, of course, 2 weeks. So we're going to plug in 14. That's good. That's the number of days it is in 2 weeks. And there's our answer, 95,675. Typically, when it comes to bacteria, obviously you can only have a whole number of bacteria, so this is one of those cases where you'd probably just round to the nearest whole number and say the answer is 95,675. All right, so that's all you're basically doing with this regression stuff. Is going to that calculator. So let's look at another example. Let me just see if any of these are stand out a little bit different. Okay, so all these regression ones are pretty much the same. So like example number 1, or problem number 1, a new theme park opened up down the street. Let's plug this data back into our calculator. So this is, again, how you would do it. Just one more time. Go to your Stat button, go to Edit, and edit your lists. So I'm going to scroll up and clear my list. So remember, you can hit Clear and Enter. Remember to hover over the top of the list, hit Clear and Enter, and the list will be gone. So now plug in the data. So we have, for months, we have 0, 1, 2, 3, 4, 5, and 6. Right? And then for average number of guests, 145, 188, 220, 260, 305, 352, and 384. All right, so now it says write a linear function. So what we're going to do, remember, go back to Stat, go over to Calculate, and now we're going to look for linear regression, right? Which looks like our fourth option here, linear regression. So remember to pick the one that it asks you to pick. Sometimes it doesn't specifically say. You kind of have to use a little bit of your intuition to know which one to pick. But this one's a linear regression. All right. So we're going to select that. And same as before, list 1 and list 2, but we're just going to go down and calculate. And it's going to give us an equation. So now look at the form of the equation. It's y equals ax plus b. So that means if it's y equals ax plus b, it's telling us a is 40.36, I guess. So we'll say y equals 40.36 x plus b, and b is 143.79. Again, I typically round to 2 decimal places. I don't know if they'll need that on the test. I'm sure it'll tell you on the actual test what to round it to. But, 40.36x plus 143.79. So again, the calculator tells you the values. You just got to put it in the function. Now it says, for number 1, write the linear function a of t. So to make it look like the way the test would want it, you'd write this instead of y, you'd write a of t. And then instead of x, you'd write t. So t plus 143.79. All right. And now again, it asks how many guests does theme park expect to average after 1 year? So again, it's in months, but you're going to plug in a value for t for 1 year, which is how many months? That's 12 months. So use that function, plug in 12 for t, and see what you get. Okay? All right, moving on, that's the regression. So remember, it's all in the calculator, okay? Go to your Stat button. Everything's going to be in your Stat button. Your Stat, you'll edit the lists, and then you go to Stat and then Calculate based on your regression, okay? All right, let's get out of that. And now the other thing is the probability stuff, okay? Probability stuff, not the hardest thing in the world. This is stuff that we've kind of been doing probably since middle school, again, which is why we typically wait to do this like at the very end of the year, because it's not the most important. Well, I wouldn't say it's not important, but it's not urgent in terms of let's get it covered in time, because a lot of you might remember how to do some of it. But if you don't, that's why we're doing this now. All right. Example: a survey asked juniors and seniors at a local high school if they were going to attend the prom. The results from the survey are shown below. Okay. So let me explain what I did here. So A, asked, what is the probability that a junior is not attending prom? So, how we're going to do this is it's going to be kind of like a fraction that we have to make, or a thing that we'll divide. All right? But probability is going to be the number of occurrences. Some people say this a little bit differently. Number of occurrences over, I guess you sort of reference this as a total number, based on whatever we're referencing. So what is the probability that a junior, okay, is not attending prom? So out of the total number of juniors, so not all the students, but just total juniors, because that's what this question is asking specifically about, how many of them are attending prom? So how many are actually attending? So juniors attending. So that's what we're going to find out. Now, all that data is in the table. The juniors that are attending prom, there's 138 of them. How many juniors are there in total? Well, what's 138 plus 87? 138 plus 87 is 225. So 138 over 225, right? And then you just calculate that in your calculator. So 138 divided by 225 is 61.3 repeating. So, and it's a decimal, 0.613. Now on your paper, you'll see that I wrote probability and then percent value. So probability is this decimal figure, and the percent value is just converting that decimal 2 places over, so 61.3%. Now the reason I put both on the paper is because I don't know what the test would ask for. On the practice test that we took, it wanted the probability, so it wanted the decimal value. But it might ask for percent, so I don't know. And again, be careful on the rounding, because it might round it differently. It might just want 0.61 if it says round to 2 decimal places, or it might just want 61%. Who knows, okay? So what's the probability that a senior is attending prom? Oh, by the way, I did the first one wrong and just realized, because it said not attending prom, but I did the ones attending prom. So not attending prom, this would be the same thing, but it'd be 87. I'm sorry. Over 225, because that's juniors not attending. So apologize for that. 87 divided by 225 would be 38.6 repeating. So change that. That would all be 38% or 0.38. So ignore all the stuff that I already put on there. Okay, my apologies. All right, let me read the question carefully. Okay, that would probably help. What's the probability that a senior is attending prom? So this is how many seniors are attending. Of seniors, there are 207 attending. And how many seniors are there in total? Because we're referencing seniors. So there are 207 plus 45, which would be 252 total seniors. So the probability would be 207 divided by 252. And that comes out to 0.82. Right? That's the probability, which is the same as 82% probability. Okay. So for your questions, or I guess your one question is this survey here. Ask high school students if they bring their own lunch, if they buy it. So what is the probability a 9th grader brings their own lunch? So this would be, okay, if you're going to work this out, you need the number of 9th graders that bring their lunch, which is 76 of them, over the total number of 9th graders, which would be 76 plus 85, whatever that total is out to. 76 plus 85 is 161. So you would do 76 divided by 161, and you get 0.47, okay, or 47%. Now, the only difference here is part C and D asks what is the probability that a student brings their own lunch. It doesn't specifically give us 9th grader or 12th grader like the other ones did. So we have to actually count up all the total students. So you would add up all of the values to get a total number of students. And then, of course, the top part would be adding up the total number that bring their own lunch. So, for example, students that bring their own lunch. So that would be the 76 plus 89 plus 92 plus 83. That's 340 students in total bring their own lunch. Out of the total number of students, which would be 85 plus 77 plus 65 plus 71. Assuming I added that up right, 638. But you added up all the people that brought their own lunch and then all the students in total. So that gave us, 340 divided by 638, which comes to be 53.53, or 53%. Okay? Brings their own. And by the way, for part D, if you look at my answer key, I wrote 1 minus 0.53. And that's because if 53% of people bring their own lunch, that means 47% of people bought it from the cafeteria, because obviously it's one or the other. So if that makes sense at all. So the difference between 100% minus, basically 100% minus 53% leaves us at 47%, or 0.47. It's just a difference. I don't have to redo the math. I don't have to add up everything again, because I know already how many people were in the other category. And that left whatever the remaining amount of people in the other. That makes sense. So anyway, that's how I did it. I hope that helps. A lot of this is used in the calculator, especially that regression stuff. This isn't the most difficult thing, but it can certainly be tricky, so be careful. All right? I'll see you guys in the next one. Bye-bye.